Okay. Hello, everyone. I'm assuming that you can hear me this time. Uh, I learned my lesson from yesterday. Um, Welcome, everybody. Today, we're going to do what we call containers from the couch, and we're going to focus on EKS Workshop. My name's Adam Keller. I'm a developer advocate on the container service team here at AWS. And next to me, I have my good friend Brent Langston for the
Hey,
intro.
I'm Brent Langston, also a developer advocate, also on the container services team. So I'm glad everyone's joining in.
Cool. So, Brent, maybe before we get started in the workshop, maybe you want to do a little bit of an overview of, kind of what we talked about yesterday and then some of the fun stuff we have in store for today.
Yeah, absolutely. I want to mention, by the way, our Twitter handles are below our names here, so definitely give us a follow. We'll try and announce, upcoming workshops, upcoming Twitch streams, and stuff like that, so you can give us a follow and look for that kind of information. That said, I totally forgot to tweet anything today, so my bad. But I'll get better about that. So yesterday, what we started was the beginning of EKS workshop, and we went over, just sort of the internal workings of how Kubernetes works, how an orchestrator works, what it brings to the table, how it solves, problems that you might have in your organization. So it was very academic yesterday. And then we got our environment set up, and that was kind of when we ran out of time. So today, what we plan to do is to start using that environment that we set up and start by building our first EKS cluster. And so, yeah, if you, by the way, have any questions along the way, throw them in the chat. We'll be addressing those as we go along, and I'm happy to try and answer them as best I can. And otherwise, let's get started.
Awesome.
So yesterday like I said, we started off with the introduction. You can see that here. By the way, you can follow along with this anytime you want. It's at eksworkshop.com. So feel free to tell all your friends, tell all your neighbors. You know, we love we love people using our resources. So definitely jump in on that website and start learning. So we went through the introduction chapter and we learned about Kubernetes and about EKS and the roles that they play in our infrastructure. And then we got to start the workshop, and we went through this chapter where we set up Cloud9. One of the things that I mentioned yesterday was that Cloud9, can pick right up where you left off. And so I thought, hey, it'll be kind of cool to actually do that. So here's my environment. This is my Cloud9. And when I pick Open IDE, everything as you left it. It's always a different subtitle, but anyway, you see the instance is stopped, so I'm not paying for it while it's not running, and it's attempting to start the instance. And once it starts the instance, it'll connect my IDE back up, and we can pick right back up where we left off. So anyway, it's kind of cool how that works.
And it's just
Um,
it kind of feeds into the the tenant of running in the cloud, where you
yeah,
pay for what you use when you use it. So
exactly. Plus, it's disposable.
yeah.
Some people would want, like, oh, let me have this massive, powerful workstation that has all my stuff installed, and I used to be that way. But now, instead, what I do for every single project, I build a Cloud9, and I have that, and when I'm done with it, I throw that away, and I name my Cloud9s after my projects, and that way I can come back to it later. Like, I was testing Bottle Rocket the other day, and someone asked me something about Bottle Rocket, and I was like, oh, I have that set up. Hang on a second, and I popped open that Cloud9, and was able to start typing away at some cool Bottle Rocket demo. So anyway,
It's awesome.
let me show you one kind of next level. piece of functionality that I think you'll also find cool if you're using Cloud9. You're probably familiar with the function, on Windows Alt Tab or on Mac Command Tab, where you can switch, between applications. Well, if you're using an IDE, it might be nice to switch to it. So in Chrome, if you click on the little hamburger button and you go to More Tools, Create Shortcut, and then you pick Open as Window, now my Cloud9 is its own little app. So I can full screen it and I can Alt Tab back and forth between my different applications. Additionally, the workshop. So here's the workshop that we're working on. I put this little plus button up here and it says install EKS workshop. So if you just pick that, boom, now you have the workshop as an application also. So between those two things, I can Alt Tab back and forth and be where I want to be and still have Chrome available for doing any kind of console work or something like that. So those were both like side notes. That they're not that something you could potentially do with any website, but I like to do them with Cloud9 and with the workshop. So let's dive back into the workshop. So where we left off was we need to try and launch a cluster. So the official CLI for launching a cluster is EKS control. This is a tool that was developed by Weaveworks in conjunction with AWS, and it tries to make installing or building an EKS cluster much easier. If you think about what you have to do without EKS control, there are CloudFormation things that you can do to help with this, but you have to build a VPC, provision subnets, multiples of them. You have to set up routing in your VPC, etc. Then, of course, you can go to the control plane, the console, and you can launch a cluster. What would that look like, real quick? Um,
And Brent,
so if I,
while you're doing that, a question came in about Cloud9,
yeah,
if it's free tier eligible, and I had responded in the chat. There is free tier eligibility with Cloud9. What's nice is it's a service. You don't actually pay for the Cloud9 service. You just pay for the EC2 instances and the storage that you're using. So if you're eligible for free tier and you use the free tier EC2 instance, you're good.
exactly.
So
So what would it look like to build a cluster in the console? You can, of course, go to the EKS console and you see it wants to know what cluster name you want to build, then what Kubernetes version you want to provision, then do you want to set up secrets encryption, tags, etc., and you pick next. So all of these choices, we can actually codify them a bit by using EKS control. So that's my preferred way of building a cluster. So let's check out how we do that. First, we need to download and install EKS control. So that's pretty simple. They do all their releases on GitHub. So I just curled whatever the latest release is from GitHub and moved it into user local bin. So let's make sure that it's executable and works. Sure enough, it is. There's also some shell completion that can be nice to have in place. So that'll set up bash completion for me. It's optional. You don't have to do it, but I like it. Okay, now big red warning here. Do not proceed unless you validated the IAM role. Yesterday we did it, but today let's just double check. So how do I check the IAM role on my workspace? Adam, do you happen to remember?
well, there's a couple
On the
ways.
spot,
No, there's a couple ways. It's an EC2 instance, right? So I can,
right?
you had showed I can click on the B in the corner. I can go to the instance. I can look at
Oh,
the
nice.
settings in
Yes.
the instance and actually see what IAM role I have attached to that instance.
Manage EC. So I'm doing it right now the way he's describing. Manage EC2 instance.
I was always the kid, by the way, in school. Like, even if I knew the answer and I got called on the spot, I froze and the answer was gone. So,
Nice. Nice.
anyways.
Okay, yeah. So that's one way. IAM role, EKS Workshop admin. That looks nice. Now, the one thing that this tells us is that the role is attached. It's still possible to have the role attached and not in use because of the way Cloud9 manages short-term credentials. Um, so there is something that we could take a look at where we use the command line sts get caller identity. And if you aren't familiar with this command, I run this all the time. This basically is just the who am I for the AWS command line. So if you just run this, what you get back is an account ID, your user ID, and then the ARN for your ID. And what we see here is, sure enough, we are using our assumed role, and that assumed role is EKS Workshop admin. And then it's attached to our instance ID. So this is exactly what we're looking for. And then, by the way, this is all like codified back here. If I click this link and validate the IAM role, um, I can actually have a nice little conditional where I'm still running get caller identity, just pulling out the ARN and looking for EKS Workshop admin, and it's returning IAM role is valid. So I'm good to go. That means I can go ahead and proceed with building my cluster.
And Brent, someone had asked about running this if they weren't running it in Cloud9, they were running it on, let's say, VS Code or their own IDE.
Right.
Would they be able to do this with the workshop?
You can. There's going to be some things, some expectations that exist for the fact that, Cloud9 is running in Linux. So if you're on a Mac, then the download links might need to be changed or something like that. And then also just having correct versions installed. Like Cube Control 118 is out, and that's the current Cube Control, but I think we're currently using 115 in the workshop. I need to go and update to 116. But 115, 116, either one of those are fine. If you do 118, then there's a chance that something in the workshop along the way we haven't tested with it and changed our command structure for it yet. So there's a chance that it could cause an issue.
Yeah, so I think the answer is yes, but for like maybe if you want to just really have a good, seamless experience with the workshop, Cloud9, is going to give you that because we've tested it on Cloud9, and that's where this has been built.
Exactly.
So,
Exactly.
cool, thanks.
Okay, so we're going to now build a config file for EKS Workshop. Now, this config file is what EKS Control is going to read and use to build our cluster. So remember those questions that we were just looking at in the console about what cluster name do you want, what cluster version, and stuff like that. All that we're answering in this file, and then we're going to run create cluster. So I'm going to go ahead and kick that off because this is going to take a while. And now we can actually come back and we can look at what are these settings. So we built our config file. We specified that's an internal EKS control thing, the API version. But our name, cluster name, so that was on the first screen of the console that I filled out. The region wasn't really on the console, but it was because I was in a region. So here I'm specifying the Ohio region because that's my default region. And then I also specified that I want to build manage node groups. And that's not something we've really talked about yet, but we'll get there today, I hope. Managed node groups are, well, let's just talk about it. Managed node groups are a way for the EKS service to actually provision your data plane on your behalf. So normally, if you think about the role of a container orchestrator, it's just to orchestrate containers on your compute. So we're starting to see expansion of that role a little bit. So now instead of you bringing your own compute and you having to manage patching it, updating it, rolling in new versions of it, and all that, day-to-day stuff, it's possible for us to actually manage that for you now. So we can do that by provisioning and managing something called managed node groups. And so with a managed node group, we're providing the AMI, we're provisioning it in your account on your behalf. So we'll still see those nodes come up, and we can look at them and see them. And although I don't have it set, we could even SSH into them if I had, added that as an option.
So,
You just
Brent,
specify the SSH key.
I
Yeah.
have to ask the question because I've heard of
Yes.
this really cool thing called Fargate. What's the difference
Yes.
between a managed node group and Fargate?
Good question. Think of it this way. With a managed, okay, so there's like three levels of interaction. There's one level where you have the most ownership over anything, and that's where you're bringing your own nodes. You can bake your own AMIs, put in your own software, whatever it is that you think you need to do, you can do it into your own AMIs, and that can be your data plane. Then a layer slightly less DIY is this managed node groups, where you can specify what kind of node, how many of them, but we'll take care of the operating system, the build of the AMI, and the software that goes on it. So we'll take care of all that for you. Then even more removed and even less for you to worry about is Fargate. And Fargate is the compute is just provided, and it's not even in your own account. You don't have to worry about paying for those instances or managing them or patching them or any of that kind of stuff. And instead, every time you launch a pod, we place it onto compute that is right sized for that pod. So it's a really, really great way to do Kubernetes pods. There are some exceptions or some gotchas that you have to watch for with Fargate. It's still very early days. For example, if you need to route traffic to a pod using classic load balancer, this is just an out there example. Fargate isn't going to work for that. It can only work with application load balancer, ALB. So we're working on getting NLB integration. I think by then we'll have a really good story for filling in and completely replacing the classic load balancer functionality. But until then, you still have the ability to have managed node groups. So it's all good. Let's take a look real quick at our progress so far, and we'll look at what EKS control is doing. So if we look, we see EKS control, we see our version, we're using region US East 2, Ohio. It discovered these availability zones, US East 2B, 2C, and 2A, and then it built subnets for those availability zones, both public and private subnets. It's going to build and use Kubernetes 1.16. I don't remember. Do I have that in my? I don't. So that's the default version that EKS control provisions. And it's building the name of the cluster in the region, and it's creating a CloudFormation stack for the cluster itself and 0 node groups, and then a CloudFormation stack, a different one, for one managed node group. So I'm curious, what do we see over here if we were to look at CloudFormation right now? Let's just take a look at what's happening. Okay, so there's my Cloud9 CloudFormation, by the way, and then we have our EKS cluster CloudFormation that's coming up. And if we look at, I like looking at events and resources, by the way. So if you've ever wondered, gosh, what happens, while all this is happening, you can see this is exactly everything that's being built. So we started off building a VPC, and we built NAT IP internet gateway. If you've ever done those yourself, you know those things take time, right? It takes a little while for a NAT gateway to come up and go healthy, and an internet gateway, and so on. And once those are healthy, then we can move on, and we can start to build out other stuff in the VPC.
And
So you
Brent,
see,
yeah, I
yes.
just wanted to say, like, when you compare this to that YAML file that you use to deploy this environment, if you were to compare this to like a CloudFormation template and
Oh,
the difference in lines of code, and actually, there's a question I wanted to that someone B Green Go 31 had asked in the chat is EKS CTL better than CDK or CDKs, or is it just preference?
CDKs is really used on a cluster. This is used to build a cluster. So I think there are two different uses. And I would actually use both of them. I would use this to provision my cluster in the infrastructure. And then once I had it up and running, I would use CDKs to actually then build and deploy my applications onto that cluster. So I grabbed, since you were talking about the CloudFormation template, I actually just grabbed this template, and it's, not compressed, but what do you call it, minified a little bit. So I'm curious. Uh, it's JSON. Let's paste it, and then let's cat through JQ.
Yeah.
758 lines of readable CloudFormation, and I didn't have to write any of this. I just had to fill in a few details, that it couldn't guess at. But otherwise, like, it's building everything with best practices. It knew to use 3 availability zones and spread out, 6 subnets, 3 private, 3 public, all that stuff. It had all that figured out. It's built in. I just had to fill in a few of the details that it wouldn't be able to guess at. So it's really cool. I love seeing this in action.
And another question came in, Brent.
Yeah.
Um, Worker nodes created by the EKS cluster, are they inherently placed in a cluster placement group, or is there no relation between the two?
I don't think there's a relationship between the two. I think the placement group is for I this is a stretch of my EC2 memory, but I might be thinking of something different. But is the placement group the thing that gives you ultra low latency between EC2 instances? And they're placed in an autoscale group,
Yes,
but not a placement group.
yeah, there you go. It looks like yes, that is what the
Okay,
question was
cool.
around.
No, I think for most use cases, what we find, I think, pretty common, what I've observed anyway, is like 1 millisecond, maybe 2 milliseconds of latency across availability zones. And for most use cases, that is perfectly fine. When you need that super low latency, what I might come in and do is build a separate node group just for that, using a placement group, and then label it, and then assign the work that is really going to benefit from having that ultra low latency. I'll assign it to that specific node group. So that would be how I would tackle that. But for this is just everyday work. Nothing that sensitive. All right, so let's see where we're at with our build. Go back to events, reload. So we have our NAT gateways coming up. That one takes a little while. We also have our control plane coming up. So since I see this, let's actually open up another console, and let's go to the EKS console. There's our control plane. It's active. That's cool. Um, so it's up and ready to go. That actually came up pretty fast. It's all the other stuff that takes a little while.
Yeah, and I think it may be cool to touch on the EKS console, and we've made quite a few improvements over the past just couple of months to the EKS console itself. So at some point, I think it'd be cool to show
Yeah,
that.
one of the things I didn't do, good point. When we first launched EKS, the whole console was a single page, and it was like this big. But now you can actually see node group information, networking information, logging information. One of the things that I didn't do in my config file was turn on control plane logging. So if I wanted to do that, for example, I could do that here in the console, and I could have API server logs turned on. And that way, those logs automatically get shipped to CloudWatch logs or authenticate or all of these if I want. So let's just turn them all on, save our changes. So that's going to kick off an update to my control plane, and it'll start shipping all of those control plane logs over to CloudWatch logs. That's something I could have done in EKS control as well. And what would have happened, what's great about having EKS control as a utility is it's more than just CloudFormation, because this is something you can't actually do yet in CloudFormation. So because you can't do it yet, what happens is we build the cluster, we build the control plane, then EKS control would come along and make the API call to turn all of those logging options on. So it's really cool that you have that ability baked into a single utility. Um, in my case, I just did it here at the console, and it's all good. Okay, so we've gotten to the point where the cloud formation for building the control plane is done. So it's built our VPC subnets and security groups and ENIs and NAT gateways and then built the control plane itself. All that's done, and now it's kicked off building the EC2 instances. So let's go take a look at EC2 real quick. And so, for EC2, we're going to have an autoscale group, the configuration. So we see 3 nodes that are initializing right now. If we scroll down and we look at autoscaling groups, I see EKS, that's my autoscale group. And then my launch configuration for that is none of these? Maybe it doesn't use launch configs. Let's take a look.
Maybe launch templates.
Oh, right. That's in a different part. You're right. That's what it uses. Thank you.
Which are great, by the way. Launch templates are pretty amazing.
They are. So there's my launch template. Cool. Let's go back and check on those instances. Still initializing, but they're running.
And
So,
it's funny. I remember the days of managing orchestrators and building these on our own, and having to, you know, figure this all out on our own, setting up auto scaling groups, instance
oh my
types.
gosh.
It was a lot of work.
It was. It was. And you had to figure it all out and then figure out how to put it in your, infrastructure as
Yep,
code, whether it was Terraform or CloudFormation or whatever. So you had to figure out each tiny little step along the way.
it's a lot of work.
So we're up. We're up and ready. We have our 3 nodes available to us. If I do kube control get nodes, boom, there they are. Um, cool. I think we're ready to go. Let's make sure that we officially test the cluster. There's my test for kube control get nodes. And then later on in the workshop, I'll probably need to know my stack name and role name. So I'm going to go ahead and set that in my environment now. This is the role that's assigned to those nodes. Um, and I think later in some of the future chapters, we attach policies to that role to open up some permissions. Okay. what should we do first? I think it might be kind of cool to deploy the Kubernetes dashboard. This is for me almost like deploying a Hello World application, because it's not something that I wrote, so it's probably not something I'll mess up. And I can deploy it and I can see it running, and then know that my cluster is working correctly. So I'm going to kubectl apply this thing out there at GitHub that is the Kubernetes dashboard. So this is the recommended way to deploy it. So I'm just going to go ahead and paste this. We don't have to get into the details of everything that it's installing or anything like that. I just want to see that it runs. And when it starts up, it actually starts up listening on port 8080. Or sorry, it starts up listening. So I'm going to start a proxy to be able to forward my traffic inward to that dashboard. So I started it up and backgrounded it. So you see it's running, and my port is 8080. The port choice is actually because of Cloud9. Cloud9 has this preview feature, but it only works on port 8080. So we're going to take advantage of 8080 a lot through this workshop. But the way you use the preview is you preview whatever's running on port 8080. This happens to be the Kubernetes API. We're going to specify that what we want is the Kubernetes dashboard. So we're going to copy this and add it to the end of our URL. Enter. And now I have the login page for the Kubernetes dashboard. Now there's something about this page where it doesn't actually let you log in if you're still in this particular pane. But if you pop this open to a real browser, this should work for us. So I've popped this out. It's now running in Chrome. And the next thing I'll do, close this, and we'll go and we'll get our token to log in. So you have to log into the dashboard using a token. And the token we can actually get using the AWS CLI. So AWS EKS get token, and then the cluster name of our cluster. If we do this without JQ, you will see that we just get back some JSON. Let's actually pretty print it with JQ. And you can see that this is a credential. It has an expiration stamp, and here's my token. So all I'm doing with the command that we're copying is I'm just pulling out just status dot status dot token. So I'm just getting the token information, which is then what we'll paste into the login page.
And just one of
Token.
the cool
Boom.
features with kubectl is just all the things you can do. Like you're able to set up a proxy, like to set up a reverse proxy on your own. It's a lot of Stack Overflow, a lot of googling, right, just to get that working. Whereas kubectl, it's just super easy, and boom. So
Totally. Yeah,
cool.
it's pretty crazy. That's I think one of the reasons that kubectl has become so popular for developers is because they do have like all of these capabilities built in, and it's all under a single command, kubectl. As long as they can run a kubectl